Okay, ladies and gentlemen, good morning. So, last time we started to look at this numerical example of moral hazard problem in banking from Greenbaum and Tucker's textbook. To refresh your memory, the story was as follows. So there's a company named Brown Bakery, and Brown Bakery needs £100 to fund their project. And Brown Bakery, after borrowing £100 from a bank, Brown Bakery can choose one of the two projects. Project S is a safe project with 90% chance of being successful, and Project R is the risky project with only 60% chance of being successful. When the bank offers £100 to Brown Bakery, it specifies interest rate R, and if the project succeeds, Brown Bakery should repay the borrowed amount 100 times 1 plus this interest rate R, and if the project fails, then Brown Bakery defaults. And we assume that the bank cannot tell the project choice, but we assume that the project outcome is observable to the bank. So the bank can tell whether the project was success or failure. But we assume that the bank cannot observe how much money the project made. So even exposed, the bank never knows which project it was. Clear? And finally, we assume that the bank wants 10% expected return. So when the bank lends £100, the bank wants at least £110 back in expectation. Okay? When the bank lends £100, Brown Bakery borrows £100 and then makes a project choice. And if the project succeeds, 1 plus R times 100 is paid to the bank. Easy, right? Let's see what happens. So what interest rate should the bank charge? Let's compute the expected payoff to Brown Bakery from selecting the safe project and from selecting the risky project. If Brown Bakery, after getting this loan with interest rate R, if Brown Bakery selects the safe project, this is the payoff to them. 90% chance of the project succeeding and making £300, and they have to repay this much, 100 times 1 plus R is the payment to the bank. So after the payment, Brown Bakery's expected payoff is 180 minus 90 R pounds. If they choose the risky project, then the project will succeed with 60% probability and make £400. So after repayment to the bank, Brown Bakery's expected payoff is 180 minus 60 R. So you can see what, no matter what the interest rate R is, the payoff is always higher when Brown Bakery selects the risky project. So Brown Bakery always prefers selecting the risky project to selecting the safe project. Okay, we got negative sign here. So the latter expression is always larger than the former expression as long as R is some positive number. So Brown Bakery always selects the risky project, even if it promises to select the safe project. The bank never knows which project was chosen. If Brown Bakery selects the risky project, then the expected payoff to the bank is, well, the probability of repayment is 0.6, and the amount of repayment is 100 times 1 plus interest rate, and our assumption is that this should be equal to £110 because the bank wants 10% expected return. So we can solve for the interest rate. The interest rate to be charged is 83.3%, not 0.833, 83.3%. If this is the charged interest rate, then Brown Bakery's payoff is Well, we use the second expression. Brown Bakery selects the risky project. Interest rate charged by the bank is 0.833. So if we substitute this, Brown Bakery's payoff is 130.02 pounds. So this is what happens in equilibrium. The bank says, okay, we can lend you 100 pounds, and we know that you will choose the risky project. We will not observe, but you will choose the risky project. This is the interest rate, 83.3%. If your project succeeds, then you should repay 183 pounds to us. And that way, bank's payoff is 110 pounds. Brown Bakery's payoff is 130 pounds. What if Brown Bakery could commit to selecting the safe project? Let's say if the project was observable, if the project choice was observable, Brown Bakery could sign a contract with loan covenant, right? Which says that if the company tries to select the risky project, then immediately the bank can call back the entire loan, something like that. If Brown Bakery could somehow commit to selecting the safe project, they cannot, but suppose they could, then the interest rate charged by the bank is much lower because, well, bank wants 110 pounds in expectation. If Brown Bakery selects the safe project, the probability of successful repayment is much higher, 0.9. So the resulting interest rate would be as low as 0.222, 22.2%. And if this is the interest rate charged, and if Brown Bakery selects the safe project, their expected payoff is, this time we use this first expression and substitute this low interest rate. So Brown Bakery's payoff would be as high as 160 pounds. Of course, that's much better for Brown Bakery, but that doesn't happen in equilibrium because if this is the interest rate charged by the bank, then Brown Bakery would select the risky project. And if Brown Bakery selects the risky project, this is not the right interest rate that the bank should charge. Now, last time I emphasized that potential moral hazard by the agent whose action cannot be observed by the principal who offers the deal. Okay? The potential moral hazard by the agent can hurt the agent himself. Okay, potential moral hazard by an agent hurts the agent himself. I emphasize that fact, and this is a clear example for that. Brown Bakery can choose the risky project because it knows that their project choice will never be detected by the bank, and because of that, their payoff is only 130 pounds. Okay, if they cannot do moral hazard, then their payoff would be 160 pounds. So it's actually hurting. The bank is getting 110 pounds either way, but it is actually hurting Brown Bakery. This type of conflict of interest between the borrower and the lender is not specific to this particular example. It often happens that shareholders want to take more risk. The shareholders want to take more risk than lenders, creditors want them to take. And that is because lenders, creditors are fixed amount claimants, while companies' shareholders are residual claimants. Lenders are fixed amount claimants because their payoff is, at most, the amount lent out times 1 plus interest rate. No matter how much profits the company makes, the maximum payoff the lenders can possibly get is 100 times 1 plus interest rate. Shareholders, on the other hand, are residual claimants. As long as the company pays out all the debt obligation, the rest belongs to the shareholders. So the more profits the company makes, the more the shareholders can get. And more importantly, the loss is limited for shareholders due to limited liability. And because of this, the shareholders want to take more risk than creditors do. And this conflict of interest is particularly large when the borrower is underwater, when the borrower is close to default or bankruptcy. This conflict of interest is particularly large. The book by Adamati and Helvin explains that. So shareholders think, okay, if we continue to take this safe strategy, we will default, but we will be able to pay back probably 90% of the debt. But in that case, we shareholders will not get anything. Why don't we take a riskier strategy? If we take a riskier strategy, and if we are lucky, maybe we can pay back all the debt, and we shareholders may get something. Very likely that such a risky strategy will fail, and we will be able to pay back only 10% of the debt, but who cares whether we can pay back 90% of the debt or 10% of the debt? Either way, we shareholders will get nothing, so let's take more risk. This happens because the potential gain side of taking extra risk for shareholders is large, while the loss side of taking risk is limited. The structure is very similar to what often happens in sports matches. Let's say you're playing football, only 5 minutes are left, you are losing by 2-0. What do you want to do? You want to take a riskier strategy. If you are lucky, you will score another 2 points and tie the game. Very likely, you will lose another 3 points or 4 points, but losing by 2-0 and losing by 5-0 are not very different. Again, the potential gain side of taking a risk is large, while the loss side is capped, limited. In that case, you want to take extra risk. How can we avoid this type of moral hazard, potential moral hazard problem by borrowers? And here comes this use of collateral. We can use collateral to mitigate this moral hazard problem. So let's introduce collateral to this setup. The setup is almost the same. Again, Brown Bakery needs £100 to finance a project. The bank can offer a loan of £100, but this time the loan contract the bank offers consists of not only of the interest rate, but also of the amount of collateral Brown Bakery should give up if the project fails. And then, after getting such a loan, after signing a loan contract, Brown Bakery selects one of the projects, the safe project or the risky project. They are the same as before. If the project succeeds, Brown Bakery pays 100 times 1 plus interest rate. Okay, this part is the same. If the project fails, then Brown Bakery gives away the collateral to the bank. The collateral is worth £3 to Brown Bakery, and today we assume that collateral is worth a little less to the bank, only 90% of C. It's often the case that collateral is worth to the borrower more than to the lender. Like your car, your computer, worth more to you than to other people. And Brown Bakery's machines and equipment and ovens are worth more to them than to the bank. Okay, so we assume that the collateral is worth only 0.9 C pounds to the bank. Again, the bank cannot tell the project choice. Project choice is a hidden action by Brown Bakery, but bank can observe the project outcome, success or failure. And we assume that bank wants 10% expected return. So when the bank lends £100, the bank wants £110 in expectation. It's almost the same. The only difference is that now collateral is included in the contract. Are you okay? Now I need a lot of patience and attention from you. Probably this is the most tedious class for this module. You will see lots of equations and graphs, so I need your attention and focus. Are you ready? Okay, question 1. Express Brown Bakery's expected utility from selecting the safe project, U of S. Brown Bakery's expected payoff from selecting the safe project. This is it. There's 90% chance of project succeeding, and the project will make £300. This is the payment to the bank, 100 times 1 plus interest rate. Before, that was it, but now we have this extra term because collateral is included. There's 10% chance of the safe project succeeding, failing, and in that case, Brown Bakery should give up something that is worth £C for them. So, now the expected payoff to Brown Bakery from selecting the safe project is 100 minus 90R minus 0.1C. These first two terms are the same as before. We have this extra term once collateral is included. Question 2. Express Brown Bakery's expected utility from selecting the risky project, project R. Given a contract C and R. R is the interest rate, C is the amount of collateral specified in the loan contract, and this is their payoff. It's almost the same. The probability of the project succeeding is now 60%, and the project will make £400. There's 40% probability of the project failing, in which case Brown Bakery has to give up £C, the collateral. So that's 180 minus 60R minus 0.4C. Still easy, right? Still easy? Are you with me so far? Like half of you are like sleeping still with your eyes open. Okay, question 3. When does Brown Bakery prefer project S, safe project? When does Brown Bakery prefer the risky project? When is it indifferent between the safe and risky projects? We compare this first expression and the second expression. If US is larger than UR, then Brown Bakery prefers the safe project. If UR is larger, then Brown Bakery prefers taking the risky project. So, we just have one inequality constraint. Inequality condition, the left-hand side is this first expression US, the right-hand side is this expression for UR. And if the former is larger, that is, if C is greater than 100R, then Brown Bakery prefers selecting the safe project. These both-way arrows mean equivalent in mathematics. If interest rate is large and collateral is small, so that C is smaller than 100R, then UR is larger, so Brown Bakery would prefer selecting the risky project. If C is exactly equal to 100R, then Brown Bakery is indifferent between selecting the safe project and selecting the risky project. Okay, from this line to this line is just a simplification of the equation. So far so good? Question 4. In the CR plane, draw a line that represents the set of contracts for which Brown Bakery is indifferent between the two projects. Draw indifference curves for Brown Bakery's payoff from selecting the safe project and their payoff from selecting the risky project, and highlight US equals 0 and UR equals 0. In what region does Brown Bakery want to accept the contract and select the safe project? These are the summaries of the previous 3 questions. We have CR plane. C is the amount of collateral, R is the interest rate, so every single dot point in this plane represents a particular loan contract. It can be high contract, low interest contract, or it can be high interest or low collateral contract. The indifference curves for Brown Bakery's utility function when it chooses the safe project should look like this. Both coefficients, the coefficient of interest rate and coefficient of C, are both they have the same signs, so the indifference lines should be downward sloping. We did basic math for this last week, so if you're not sure, please go back to the video from last week. Indifference lines for UR, Brown Bakery's UTT from selecting the risky project, should be steeper according to that math. And yeah, let's highlight the utility, the indifference line for UTT being 0. Okay, and notice that the utility for Brown Bakery goes up in this direction. So the origin is the highest. For Brown Bakery, for the borrower, interest rate isn't good, collateral isn't good. If the interest rate is 0 and the collateral is 0, then that's the best for the borrower. So utility goes up in the direction of the origin. And we can, the intersection between US equals 0 and UR equals 0 is this point when collateral is £180 and the interest rate is 1.8, 180%. The line that represents the set of contracts for which Brown Bakery is indifferent between US and UR is represented by C equal 100R, like this. If the contract is on this line, C equal 100R, Brown Bakery is indifferent between the safe and risky project. In this blue area below this line, C is greater than 100R, so US is greater than UR. If the contract falls in this blue region, then Brown Bakery prefers selecting the safe project. If the contract is in this red region, then Brown Bakery, with such a contract, Brown Bakery prefers the safe project to the risky project, and Brown Bakery gets actually non-negative utility from selecting the safe project, US being non-negative. Okay, so if the contract is in this area, Brown Bakery would be happy to get the loan and select the safe project. Question 5. Do you have any question? Okay, question 5. Express the bank's expected payoff, V, as a function of the contract variables C and R when Brown Bakery selects the safe project. Okay, this time the bank's payoff, bank's expected payoff. The bank's payoff, of course, depends on the loan contract C and R. The bank's payoff also depends on the project choice by Brown Bakery. So let's assume for now that Brown Bakery will select the safe project. And let's compute bank's expected payoff. And our assumption is that this is at least £110. This is bank's payoff, expected payoff, when Brown Bakery selects the safe project. If Brown Bakery selects the safe project, the probability of repayment is 90%, and this is the amount of repayment the bank can get from Brown Bakery. There's 10% chance of the project failing. In that case, Brown Bakery will hand over the collateral, which is worth C times 0.9 pounds to the bank. So if we simplify this expression, that's 90 plus 90R plus 0.09 C. Let's draw indifference lines for this, and remember, US has this expression, so by comparing this expression and this expression, we can see that the lines, indifference lines for V, are flatter than those for US. If you are confused, go back to that math preliminary we did last week. So indifference lines for V should look like these dashed purple lines. For the borrower, the utility goes up in this direction, in the direction of the origin. For the lender, for the bank, utility is higher if you move away from the origin. And this is because for the bank, high interest rate is good, high collateral is good. For the bank, the contract should be above this line, which corresponds to V equal 110, because bank wants at least 10% expected return in our assumption. So this is the maximum acceptable level for the bank. And the intersection between this V equal 110, this line, and this line, C equal 100R, is given by 20.20 and 0.2020. So if the collateral is 20.2 pounds, and the interest rate is 0.2020, then the bank is getting at least 110, and Brown Bakery is indifferent between the risk and safe projects. Two more questions. Question 7. If the deal is made so that the bank maximizes, so that the bank's profit is maximized, which point should be offered? If the deal, the loan contract is arranged so that the bank's profit is maximized, which point should be offered? Suppose there are only a few banks, and there are many potential borrowers. In that case, bank is almost a monopolist, so the bank can exploit the Brown Bakery. Okay? Imagine such a situation. So the bank can optimize the bank's profit. This is the mathematical formulation of the bank's problem. The objective function is their own payoff, V, assuming that Brown Bakery will select the safe project. Yes, the bank wants Brown Bakery to select the safe project. Of course, the bank cannot force Brown Bakery to select the safe project because project choice is not observable. They choose the contract R&C, interest rate and contract, and this contract should be such that Brown Bakery will voluntarily select the safe project. So, C should be no smaller than 100R. This is the incentive compatibility constraint for Brown Bakery. Again, this constraint is necessary. Bank should satisfy this constraint because the bank cannot force. Okay? Because the project type is not, project choice is not observable. Of course, Brown Bakery's payoff from selecting the safe project should be non-negative, otherwise Brown Bakery wouldn't bother to come to the bank to get the loan. So we need the participation constraint for the Brown Bakery. So we have two inequality constraints. You can solve this problem using Excel solver, but because we have already drawn this whole diagram, we can solve this problem graphically. The set of loan contracts that satisfy these two inequality constraints is this red region. Okay, as long as the loan contract is in this red region, Brown Bakery would come to the bank to get the loan, and Brown Bakery would choose the safe project without being forced. The objective function is represented by these indifference lines, these dashed purple lines, which take a higher value if it is away from the origin. So you can see that the highest value for the bank can be achieved at this king. So yes, that's the solution to this problem. If the bank maximizes its profit, then point A should be offered. So the required collateral is 180 pounds. The charged interest rate is 180%. And at this point, Brown Bakery is completely exploited, getting zero utility. What if the deal is made so that the borrower's utility is maximized? If there are many banks, and if there are relatively few borrowers, if there are many banks and relatively few borrowers, then the banking industry is so competitive that the bank has to try to maximize the customer's utility, okay? Otherwise, the Brown Bakery would go to some other bank, okay? If let's assume that the banking industry is so competitive that the bank has to maximize Brown Bakery's utility. In that case, this is the mathematical problem the bank faces. Now the objective function is Brown Bakery's utility. And the bank still wants Brown Bakery to voluntarily select the safe project. So the objective is Brown Bakery's payoff from selecting the safe project. The bank selects the loan contract, interest rate, and collateral. There are two constraints. Again, we have this incentive compatibility constraint to make sure that Brown Bakery will voluntarily select the safe project. So C should be no smaller than 100R. We also have participation constraint for the bank, because you cannot say, oh, when interest rate is 0 and collateral is 0, that's the best for Brown Bakery. You cannot say that because bank wants at least £110 in expectation. So V should be no smaller than 110. The set of loan contracts that satisfy these two constraints is this green region. As long as the loan contract is in this region, the bank is getting at least £110 and Brown Bakery will select the safe project. The objective function US is represented by these flatter black lines, whose value increases in the direction of the origin. So you can see that the optimal point is achieved at this kink. Okay? So if this is the problem, point B is selected by the bank. Collateral is £20.2. The charged interest rate is much lower, only 20.2%. And at this point, the bank is getting £110 in expectation, so the bank is completely exploited. If this point is offered by the bank, Brown Bakery's payoff is £159.8. If you remember, without the use of collateral, what happened? Without collateral, the bank charges very high interest rate, 83.3%. Brown Bakery accepts that deal, and Brown Bakery selects the risky project. Their payoff was £130. Now, with the use of collateral, Brown Bakery is induced to select the safe project. The bank is happy to charge very low interest rate, and Brown Bakery's payoff is £159. It's not as good as when the project type was observable, but still it's a lot of improvement. Now, so these two, point A and point B, are like very extreme situations. At point A, the bank has full bargaining power and the bank completely exploits Brown Bakery. At point B, the banking industry is so competitive that the bank is completely exploited by Brown Bakery. In reality, any point between these 2 points, any point on this segment can realize, depending on the bargaining powers of the lender and the borrower. If the lender's bargaining power is large, then the achieved point would be close to A. If the borrower's bargaining power is large, then the achieved point would be close to point B. However, no matter which point on this segment realizes, none of them are Pareto efficient or Pareto optimal. You can always find a point that Pareto dominates these points. Think about point A, and think about this green triangular region to the northwest of point A. Pick up any point from this green triangle. If you compare that point and point A, you can see that with such a point, Brown Bakery's utility from selecting the safe project would be higher than at point A. Remember, US is larger in this direction, in the direction of the origin. And bank's payoff, represented by these purple dashed lines, are also higher at this point in this green area than at point A. So that point would be better for both for the bank and Brown Bakery than point A. But again, that point cannot be achieved. That point is not achievable or feasible. Why? Because if this point is offered by the bank, then Brown Bakery would not choose the safe project. Brown Bakery will choose the risky project. Remember, for Brown Bakery to select the safe project, the points should be in this red region. So if this point in this green area is chosen, then the Brown Bakery will choose the risky project. If they do, then bank's payoff is no longer V. Okay, V is not their payoff because this V, bank's payoff V, assumes that Brown Bakery will select the safe project. Similarly, if you compare point B and any point in this green, small green area in the northwest to this point B, the point would Pareto dominate point B, but that point cannot be achieved because of this potential moral hazard problem. And that's why people, economists don't call these points on this segment first best. These points are called second best. Okay, they are not Pareto efficient. Yes?
Can we say that they're Nash equilibrium?
Nash equilibrium? Which points? These points?
Yes.
To talk about Nash equilibrium, we should specify what the game is and what's the timing and what's their strategy. Who makes choice first and what kind of choices they make. So I have to think about it. Like, I have to reformulate this in terms of like kind of game. Any other question? Let me make two comments on that example. The first comment is about capital requirement. Equity requirement. Okay, in that example, collateral is used to mitigate potential moral hazard problem in banking. Another typical solution to mitigate moral hazard problems in banking is equity requirement or capital requirement or equity capital requirement. So someone wants to borrow £100 to fund their project. The bank says, okay, you pay £20 out of your pocket, we can lend you £80, together you have £100, you can fund your project. Now the borrower has to pay £20 out of his pocket, and that is called equity. The idea is that once his own money is at the stake, the borrower should be more careful, more cautious about risk-taking. That's called equity requirement. Still, with such an equity requirement, the moral hazard problem does not completely go away because borrowers still have some limited liability. If the project turns bad, if the project becomes nothing, then what? The loss of the borrower is £20, the loss of the lender is £80. So the maximum loss the borrower can incur is limited to £20. So there is still a limited liability, but still, it's better than nothing. Equity requirement mitigates the moral hazard problem by the borrower because his own money is at stake and he is more cautious about risk-taking. In Martin Hellwig's book, they like this example of mortgage. So Kate wants to buy a house. The house costs £100. The bank says, okay, Kate, you pay £20 out of your pocket. We can lend you £80. Together you have £100. You can buy the house. This £20 is equity in the context of mortgage, It's called down payment, but the idea is the same. If the house price goes up, that's good for Kate. If the house is completely destroyed, the loss of Kate is £20, the loss of the bank is £80. So if the mortgage is non-recourse loan, we studied what non-recourse loan is in week 3. If the mortgage is non-recourse loan, Kate has limited liability. The maximum loss Kate can incur is £20. So the structure is the same. In mortgage, you have down payment, non-recourse loan, house price can go up or go down. In corporate finance, there's equity, limited liability, the project can go well or go bad. Okay, that's equity requirement. The second comment. You might think that previous example is not very interesting because it's only about the relationship between a bank and some local bakery. But you know, the company doesn't have to be local bakery. It can be some construction company or manufacturer. It can even be a bank. After all, these large banks like Barclays, Lehman Brothers, Morgan Stanley are also companies. And these banks are also companies, and they have to borrow money from investors and creditors. And the shareholders of these banks have incentive to take a lot of risk. They have incentive to invest in risky assets, risky borrowers, and risky projects. And the creditors of these banks have almost no idea how much risk these bank shareholders are taking. Okay, so don't be fooled by these labels. These are just labels. You can change the label from Brown Bakery to Barclays, and you can apply the same model to get, insight. That's the beauty of economic models. Stories can be very different, but often different stories have very similar structures. So, okay, there is moral hazard problem in banking. When a bank borrows money from creditors and investors, collateral can be used, equity requirement can be used to mitigate such potential moral hazard problems by banks, but these solutions are not perfect solutions. So, yes. I guess that's it. Thank you for coming in early morning, and I'll see you next week.